You think you're touching your screen right now, don't you? Your finger pressed against glass, skin making contact with surface. But what if I told you that's impossible? What if your finger has never actually touched anything in your entire life? Not your screen, not your coffee mug, not another person's hand. Never. What's stopping you? What's creating that sensation of contact when there's actually empty space between your atoms and everything else? Most people have never really thought about this. They just accept it. Things touch other things. That's how the physical world works. That's just how it is. But that's not an answer. That's just repeating assumptions. When you really ask what's happening when you touch something, when you dig into what's actually creating that sensation, you discover something so strange, so fundamentally different from everyday experience that it changes everything you think you know about physical reality. You're not feeling contact. You're feeling electromagnetic forces acting across empty space. Forces so powerful they could tear apart mountains, yet so precisely calibrated that they create the perfect illusion of solid matter. And once you see this, once you understand what's really happening, you can never experience touch the same way again. Let's start with what everyone knows. You reach out, you grab a coffee mug, your hand closes around the ceramic surface, you feel the smoothness, the temperature, the weight, contact, physical, direct contact between your skin and the object. This is the foundation of how we understand the physical world. Things touch other things. They push, they pull, they collide. Everything we've ever felt, every sensation of pressure or texture or resistance comes from this basic fact of contact. Except it doesn't. Here's where things get strange. Take that same mug, hold it up to a powerful microscope. Look at the surface where your finger was touching. Zoom in. Keep zooming, past the ridges and valleys of your fingerprint, past the dead skin cells, past the moisture. Keep going, down to the molecular level, down to the atomic level. Your finger is made of atoms, carbon, hydrogen, oxygen, nitrogen, arranged in complex molecules, but ultimately just atoms. The mug is made of atoms too, silicon, aluminum, oxygen, arranged in crystal structures, but again, just atoms. Now, when you were touching the mug, what was happening between these atoms? If you're curious about how reality works at this level, and you should be because it changes everything, consider subscribing to Reimagine the Physics. We explore the counterintuitive truth about the physical world, breaking down the illusions that hide how things really work. Hit that notification bell and share this with someone who thinks they understand touch. They don't. None of us do, until we see what's actually happening. Here's what atoms actually look like. Not the planetary model you learned in school. That's completely wrong. An atom is mostly empty space. Mostly. If you scaled up an atom to the size of a football stadium, the nucleus would be a marble at the center, and the electrons would be, well, they wouldn't be anywhere specific. They'd be probability clouds, regions where they might be found, spread throughout the entire stadium. So when your finger approaches the mug, when billions of atoms in your skin approach billions of atoms in the ceramic, what happens? Do they bump into each other like tiny billiard balls? No, the atoms never touch. They can't touch. They're mostly empty space. And the parts that aren't empty space, the electrons, aren't solid particles anyway. They're quantum probability distributions. There's nothing solid to touch. But something stops your finger from passing through the mug. Something pushes back. That something is the electromagnetic force, and it's so powerful, so precisely calibrated, that it creates the illusion of solid contact. Here's how powerful this force is. Take two electrons and place them 1 centimeter apart. The electromagnetic force pushing them apart is about 1042 times stronger than gravity pulling them together. That's 1 followed by 42 zeros. The electromagnetic force is so incomprehensibly stronger than gravity that, for individual particles, gravity might as well not exist. Now, in normal matter, you have equal numbers of positive and negative charges, protons and electrons. The enormous repulsive forces between like charges are almost perfectly balanced by enormous attractive forces between opposite charges, almost perfectly. And that almost is everything. When your finger approaches the mug, here's what actually happens. The electrons in your finger's atoms start pushing against the electrons in the mug's atoms, even when they're still far apart by atomic standards, even when there are multiple atomic diameters between them, the electromagnetic force is already acting. As your finger gets closer, this repulsion gets stronger, much stronger. The force follows an inverse square law, so small changes in distance create large changes in force. By the time your finger feels like it's touching the mug, the electromagnetic repulsion has become so strong that it perfectly balances the force you're applying with your muscles. You're not feeling contact, you're feeling electromagnetic repulsion across empty space. Think about what this means for everything you've ever touched. Every handshake, every hug, every time you've picked up an object or felt a texture. None of it was contact in the way you imagined. It was all electromagnetic forces acting across tiny gaps. The keyboard you're typing on? Your fingers never touch the keys. They hover a few atomic diameters above them, held back by electromagnetic repulsion so strong it feels like solid contact. The chair you're sitting in? You're not actually sitting on it. You're floating above it, supported by electromagnetic forces pushing up from the chair's atoms against the atoms in your body. The ground beneath your feet? You're not standing on solid earth, you're hovering above it, held up by the same electromagnetic repulsion that keeps the atoms in the ground from interpenetrating with the atoms in your shoes. This raises an uncomfortable question. If nothing ever actually touches anything else, then what is solid matter? What makes something feel solid? The answer is going to change how you think about physical reality. But first, let's make this concrete with a simple experiment you can do right now. Press your finger against the screen again. Feel that resistance? Now, press harder. Notice how the screen pushes back with exactly the right amount of force to balance what you're applying. It's not giving way, but it's not overwhelmingly strong either. It's precisely calibrated. That precision is not accidental. It's the electromagnetic force adjusting itself in real time to your pressure. As you push harder, more electron clouds become involved in the repulsion. The force scales up almost instantaneously. This is why objects feel solid rather than mushy or inconsistent. Now try this. Tap the screen lightly with different fingers. Each tap feels the same, doesn't it? But here's what's remarkable. No two of those taps involved identical atoms. The atoms in your fingertip are constantly vibrating, constantly moving. The atoms in the screen's surface are doing the same. Every tap is a completely different configuration of particles, yet the electromagnetic force creates an identical sensation of contact. This consistency across constantly changing atomic arrangements reveals something profound about how the electromagnetic force works. It's not dependent on specific atoms being in specific places. It's a field effect, a property of space itself that responds to the presence of charged particles wherever they happen to be. Solidity is not a property of matter. It's an emergent phenomenon created by electromagnetic forces. When you press on a table and it doesn't give way, that's not because the table is made of solid stuff. It's because the electromagnetic forces between the atoms are so strong and so precisely balanced that they create the appearance and feel of solidity. But this creates a deeper puzzle. If atoms are mostly empty space, and if the electromagnetic forces are what create the sensation of solidity, then why can't you just push harder and force your finger through the table? Why does the resistance feel absolute? The answer reveals something profound about the nature of matter itself. Those electromagnetic forces aren't just strong, they're incredibly responsive. As you push harder against an object, more electrons become involved in the repulsion. The force scales up almost instantly to match whatever pressure you apply. Push twice as hard, and twice as many electrons push back. Push 10 times as hard, and the electromagnetic response increases proportionally. This is why objects feel solid rather than squishy. The electromagnetic forces don't just resist deformation, they resist it with whatever strength is necessary, up to the point where the molecular bonds themselves start to break. When you do manage to break something, what's actually happening? You're not breaking solid matter. You're overcoming electromagnetic forces. You're forcing electrons in different atoms so close together that their mutual repulsion overwhelms the attractive forces holding the molecular structure together. A piece of glass shattering, wood splitting, metal bending. None of these are the breaking of solid objects. They're the rearrangement of electromagnetic force patterns. But here's where it gets even stranger. The electromagnetic force doesn't just create the illusion of touch, it creates all physical sensation. When you feel heat, what you're actually feeling is the increased motion of atoms, which translates into stronger electromagnetic interactions. The atoms aren't moving faster because they're hot in some absolute sense. They're moving faster, and that increased motion creates more frequent and more intense electromagnetic encounters with your skin's atoms. When you feel cold, you're feeling the reduced electromagnetic activity as atoms move more slowly. When you feel texture, smooth or rough, soft or hard, you're feeling the pattern of electromagnetic forces created by the microscopic landscape of atomic arrangements. Even pain is electromagnetic. When you cut yourself, you're not feeling damaged tissue directly. You're feeling the electromagnetic chaos as cellular structures are disrupted, as the carefully organized electromagnetic patterns that maintain living tissue are broken apart. Every physical sensation you've ever had, every feeling of pressure, temperature, texture, even pain, is your nervous system's interpretation of electromagnetic forces acting across tiny spaces between atoms that never actually touch. This leads to a startling realization. Your entire sensory experience of the physical world is based on forces acting at a distance. Action at a distance, the idea that objects can influence each other without touching, was once considered impossible, almost magical. But it's not the exception, it's the rule. But let's pause here because this creates a paradox that most people never think about. If electromagnetic forces are what create the sensation of solidity, and if these forces act across empty space, then why does anything feel different from anything else? Why does metal feel different from wood? Why does silk feel different from sandpaper? The answer lies in the patterns. Every material has a unique atomic structure. The atoms are arranged differently, they vibrate at different frequencies, they interact with neighboring atoms in characteristic ways. When your finger approaches different materials, it encounters different patterns of electromagnetic force. Consider wood versus metal. Wood is mostly carbon-based organic molecules arranged in complex, irregular patterns. Metal is atoms arranged in regular crystal lattices. When your skin's electromagnetic field interacts with wood, it encounters a chaotic, varied pattern of forces. Some atoms are closer together, some further apart. Some are held more tightly in their bonds, others more loosely. This creates a complex electromagnetic signature that your nervous system interprets as the texture and feel of wood. Metal, on the other hand, presents a much more regular electromagnetic pattern. The atoms are arranged in precise geometric arrays. The electrons are more mobile, more able to respond to electromagnetic disturbances. This creates a different signature, smoother, more conductive, often cooler to the touch because it conducts heat, electromagnetic energy, more efficiently. The difference between rough and smooth surfaces, it's electromagnetic topography. A smooth surface presents a relatively uniform electromagnetic field. A rough surface creates a chaotic landscape of varying field strengths as your finger encounters peaks and valleys at the atomic level. Temperature is electromagnetic motion. Heat is not a substance. It's the increased vibrational motion of atoms. When something feels hot, you're feeling the increased electromagnetic activity as atoms move more energetically. Cold is the opposite. Less electromagnetic activity, slower atomic motion. Gravity acts at a distance, the electromagnetic force acts at a distance. The strong and weak nuclear forces act at a distance. All four fundamental forces of nature act at a distance. Contact forces, the kind you experience every day, don't actually exist. They're approximations, useful fictions that work at human scales but break down when you look closely at what's really happening. This has profound implications for how we understand matter itself. If atoms never touch, and if all forces act at a distance, then what makes an object a single unified thing? Why doesn't your coffee mug just fall apart into individual atoms? The answer is that it's constantly trying to. Every atom in every object is simultaneously being pushed and pulled by electromagnetic forces from every other atom. What we call solid matter is actually a dynamic equilibrium, a constant balance of forces that creates the appearance of stability. Your coffee mug exists as a coherent object because the electromagnetic forces between its atoms have found a configuration where all the pushes and pulls balance out. It's not static solidity, it's dynamic stability. And this dynamic stability extends to your own body. You are not a solid object. You are a temporary pattern of electromagnetic forces. Every atom in your body is held in place by the same electromagnetic repulsion and attraction that creates the illusion of touch. You are, in a very real sense, a standing wave in the electromagnetic field. The atoms in your body are constantly being replaced. Every cell is regularly rebuilt from new atoms. The carbon in your muscles, the calcium in your bones, the iron in your blood, none of these atoms are permanent residents. They cycle through, stay for a while, then leave. What remains constant is not the matter, but the pattern of electromagnetic forces that organizes that matter into the structure you call yourself. This is perhaps the most unsettling implication of understanding touch as electromagnetic force. You are not a collection of atoms. You are a pattern of forces. The atoms are just temporary participants in that pattern. 7 years from now, almost every atom currently in your body will have been replaced, yet you will still be you because the electromagnetic pattern persists. The entire physical world is revealed to be patterns of activity rather than collections of objects. Now, let's bring this back to touch. When you reach out and touch another person, what's really happening? The electromagnetic forces from the atoms in your skin are interacting with the electromagnetic forces from the atoms in their skin. Information is being exchanged, not just pressure and temperature, but the electromagnetic signatures of two complex organized patterns of forces temporarily coming into proximity. You never actually touch them, but in a deeper sense, you're more intimately connected than simple contact could ever be. You're experiencing a direct interaction between the fundamental forces that organize your existence and theirs. Consider a handshake. Two people extend their hands, fingers interlace, palms press together. It feels like the most basic form of human physical connection. But what's actually happening is far more profound. The electromagnetic patterns that maintain the structure of your hand are interacting with the electromagnetic patterns that maintain the structure of theirs. Information is being exchanged at the atomic level, not just pressure and temperature, but the electromagnetic signatures of two complex biological systems momentarily synchronizing their force fields. The warmth you feel isn't just heat transfer, it's the electromagnetic activity of their cellular processes affecting the electromagnetic activity of yours. When you feel their pulse through their palm, you're not feeling blood moving through vessels. You're feeling the rhythmic electromagnetic disturbances created by their heart's electrical activity propagating through the organized electromagnetic pattern of their body. A hug becomes even more remarkable. The entire electromagnetic field that constitutes your body is enveloping and being enveloped by the electromagnetic field that constitutes theirs. You're not just touching, you're temporarily merging force patterns. Your bioelectric field and theirs are overlapping, creating a combined electromagnetic signature that exists only during that embrace. This isn't metaphor or poetry, this is physics. When two complex electromagnetic patterns like human bodies come into close proximity, they create interference patterns, resonances, synchronized oscillations. Some of what you feel during physical intimacy is the electromagnetic harmony between two organized biological systems, and children understand this instinctively, even if they can't articulate it. Watch a child reach for a parent's hand or curl up against someone they trust. They're seeking not just comfort, but electromagnetic connection. They're drawn to the stabilizing influence of a mature, well-organized bioelectric field. It's why human touch is so fundamental to healthy development. We are literally electromagnetic beings learning to regulate our patterns through interaction with other patterns. But this understanding of touch as electromagnetic interaction raises questions about isolation and connection in the modern world. If physical touch is how electromagnetic patterns synchronize and stabilize, what happens when we reduce touch? What happens to isolated individuals who go days or weeks with minimal electromagnetic connection to other human patterns? The answer may explain why solitary confinement is so psychologically devastating, why social isolation creates not just emotional, but physical health problems. We are electromagnetic beings that need electromagnetic connection. This isn't just an academic distinction. Understanding touch as electromagnetic interaction rather than mechanical contact changes how we think about connection, about the boundary between self and world, about what it means to be a physical being in a physical universe. Every time you touch something, you're not making contact with an external object. You're experiencing the interaction between the electromagnetic field that organizes your body and the electromagnetic field that organizes everything else. The boundary between you and the world is not as clear as it appears. In fact, there is no clear boundary. There are only regions where electromagnetic forces are organized in different patterns. The pattern you call your hand and the pattern you call the table are both temporary organizations in the same underlying field. This is why touch is so fundamental to human experience, why it's so emotionally powerful. You're not just getting mechanical information about surfaces and textures, you're directly experiencing the electromagnetic nature of reality. You're feeling the forces that hold the universe together. And now that you know this, pay attention the next time you touch something. Notice that what you're feeling isn't contact, it's force. It's the electromagnetic field responding to itself, creating the sensation of a solid world out of mostly empty space and invisible forces. You'll never touch anything in your entire life, but you'll spend every moment surrounded by and made of forces so powerful they can create the perfect illusion of contact. The next time someone tells you they understand the physical world, ask them this: what are you actually feeling when you touch something? If they say the object, they don't understand. If they say electromagnetic forces acting across empty space, they're beginning to see reality as it actually is. And that's just the beginning. Once you realize that touch is an illusion created by invisible forces, you start to wonder, what other aspects of reality are not what they appear to be? Subscribe to Reimagine the Physics if you want to keep questioning the assumptions you didn't know you were making. The physical world is far stranger than it appears, and understanding that strangeness is the beginning of understanding how reality actually works. You can't unsee this now. Every surface you touch, every object you handle, every physical sensation you experience, you'll know that it's all electromagnetic forces acting across empty space, creating the elaborate fiction that solid matter exists. Reality is not what you touch. Reality is what makes you think you're touching anything at all.